Lesson 2, Window Aggregate Functions. Part 1, Partitioning. The partitioning element allows you to restrict the window to only those rows that have the same values in the partitioning attributes as the current row. Some think of the partitioning element like grouping and some think of it like correlated subqueries, but it's actually different from both. Unlike grouping, partitioning is specific to one function's window and can be different for different functions in the same query. Unlike correlated subqueries, partitioning filters rows from the virtual table provided to the select phase as input, as opposed to starting with a fresh view of the data and needing to repeat all constructs that appear in the outer query. The following query invokes two window sum aggregate functions, one without partitioning and another partitioned by custod. The following query mixes detail elements and window aggregate functions to calculate the percent of the current order value out of the grand total, as well as out of the customer total. Part 2, Ordering and Framing. Framing is another option that enables you to further restrict the rows in the window partition. The ordering element plays a different role for window aggregate functions than for ranking, distribution, and offset functions. With aggregate functions, ordering just gives meaning to the framing option. Once ordering is defined, framing identifies two bounds in the window partition, and only the rows between those two bounds are filtered. The window frame clause can include three parts and takes the following form. In the window frame units part, you indicate rows or range. The former means that the bounds, or endpoints, of the frame can be expressed as offsets in terms of the number of rows of difference from the current row. The latter means that the offsets are more dynamic and expressed as a logical value difference from the current rows, only, ordering attribute value. Using rows as the window frame units part means that you indicate the frame bounds as offsets in terms of the number of rows with respect to the current row. The standard rows clause supports the following options, all of which are implemented in SQL Server 2012. These options are probably straightforward, but just in case they're not, I'll provide a brief explanation. For the low bound of the frame, unbounded preceding means there is no low boundary point. N preceding and N following specifies a number of rows before and after the current one, respectively, and current row, obviously, means that the starting row is the current row. As for the high bound of the frame, you can see the options are quite similar, except that if you don't want a high boundary point, you indicate unbounded following, naturally. As an example, consider the following frame. The window frame created for each row contains all rows from the first order month through the current row. Note that you can use rows unbounded preceding as a shorthand way of saying rows between unbounded preceding and current row. But if you omit the window frame extent part altogether, just leaving the partitioning and ordering parts, you get something a bit different by default. I'll get to this later when discussing the range option. This query uses the aforementioned frame specification to calculate a running total quantity for each employee and order month. Recall that you can use a more concise form to indicate the frame while retaining the same meaning. The calculation that generates the attribute pt defines a frame in terms of rows between one preceding and one preceding. This means that the frame includes just the previous row in the partition. Similarly, the calculation that generates the attribute xt defines a frame in terms of rows between one following and one following, meaning that the frame includes just the next row. The calculation that generates the result attribute of kt defines a frame of rows between one preceding and one following, meaning that the frame consists of up to 3 rows. Run the code to create and populate a table called T1. Consider the following query, which is followed by its output. Observe that different rows that share the same partitioning, inapplicable, In our case, an ordering values get different counts. That's because ordering among peers, rows that share the same partitioning and explicit ordering, is arbitrary, in other words, left to the implementation. In SQL Server, this simply depends on optimization. If you need to guarantee a deterministic result, you should make sure that the combination of partitioning and ordering elements is unique. You can achieve this by adding a tiebreaker to the ordering specification, in our case, by adding the primary key column. Now the query is deterministic, meaning that there's only one correct result. Part 3, the rank E window frame extent option. Standard SQL also supports specifying the window frame extent using the range option. As of SQL Server 2012, range is not implemented fully. It is currently supported only with unbounded and current row window frame delimiters. What's also still missing is support for a temporal interval type that, combined with full support for the range option, would provide a lot of flexibility in the frame definition. As mentioned, SQL Server 2012 does support the range option with unbounded and current row as delimiters. For example, the window function in the following query calculates the running total quantity from the beginning of the employee activity until the current month. As mentioned, if you don't indicate the upper bound, the default is current row. So instead of using range between unbounded preceding and current row, you can use the shorter form of range unbounded preceding. This window frame extent, as it turns out, is also the default when you indicate window ordering without an explicit window frame extent specification. So the following query is logically equivalent to the last two. If you carefully follow the examples with both the rows and range options, at this point you might wonder whether there's any difference between the two when using only unbounded and current row as delimiters. The option rows between unbounded preceding and current row, or the equivalent rows unbounded preceding, ends the frame at the current row and doesn't include any further peers. With range, when the upper bound is current row, by default peers are included. Even though the terminology is current row, it actually means current ordering value. Part 4, Distinct Aggregates. SQL Server 2012 doesn't support using the distinct option with window aggregate functions. For example, suppose that you need to query the order values view and return with each order the number of distinct customers that were handled by the current employee up to, and including, the current date. What you want to run is the following query. But because this query is not supported, you need a workaround. One way to address this need is with the help of the row number function. Using the row number function, you can assign row numbers partitioned by impid and custod, and ordered by order date. Observe that only the first occurrence of each custod value for each employee based on order date ordering is returned, and nulls are returned instead of the subsequent occurrences. The next step is to define a CTE based on the previous query, and then apply a running count aggregate to the result of the case expression. Part 5, Nested Aggregates. It's perfectly valid, albeit strange at first sight, to apply a window aggregate to a window that contains rows with attributes produced by grouped aggregates. I say strange because at first sight an expression like sum val in a query usually doesn't seem right. But it could very well be. The grouped aggregate sum val calculates the total values of all orders for each employee. This means that the result of the underlying query has a row for each employee, with that total. Then the window aggregate calculates the total of all employee totals, in other words, the grand total, and divides the grouped aggregate by the window aggregate to calculate the percentage of the employee total out of the grand total. It can be easy to see the logic behind the nested aggregates if you think of the query in two steps. The first step calculates the grouped aggregate. You can think of this result as being the starting point for further window aggregation. So you can apply a window sum aggregate to the expression that the alias emptitle represents. Note that you can avoid the complexity of direct nesting of aggregates by using table expressions such as CTS. You can define a CTE based on the query that computes the grouped aggregate and have the outer query compute the windowed aggregate. Consider another example for complexities related to windowed and grouped functions. When you run this query, you get the following error. The outer count isn't a grouped aggregate, rather, it's a window aggregate. As such, it can operate only on elements that would have been valid if they were specified alone, namely, not as input to the window aggregate. What you need to do is apply a window sum aggregate with a frame implementing a running total concept to a grouped count aggregate that counts distinct occurrences. Do you want to learn new skills in the fastest and most effective way? Visit learnwithvideotutorials.com.